Um, okay, once again, good afternoon to you all. We are here for the introductory session on the big data and Hadoop, which is which is the most talked about topic today. And I'm here to deliver the intro session on behalf of IT Skills Training Services. They're one of the leading quality training providers and across India, and they deliver the trainings with world-class infrastructure and dedicated trainers. Now, other than Big Data and Hadoop, they are also more prevalent in other courses such as Azure Computing and Digital Marketing, PMP, as you see in their website. This is their website, itskillstraining.com. And we are here in the Big Data and Hadoop today, which is more of an introductory session to get you started on what Hadoop is all about, what is big data, and how are we going to address the challenges in the big data industry, and what are the career opportunities that exist. Now, if you guys have any questions, feel free to interrupt on the chat window so I could stop and listen to you. If it's going to be more elaborative, then we can move it to the end of the session, at the Q&A session. Now, we have to understand what big data is all about for this part of the session. Now, as I'm talking to you, there is so much of information floating across the internet, passing across every minute and every second from computers to computers and mobile phones to another mobile phones. Now, if you guys have seen this movie, Interstellar, there is this hero, Matthew McConaughey, who travels beyond the space into something called a wormhole, and then it's a 10th dimension travel he does, and then he changes back the sequence of events in time. Now, internet is something like a space-time travel because there's humongous amount of information that flows across it, and this information is vital for us to enable a decision making of the future by changing the sequence of events which is learned by the information that is put onto the internet. So if you could see the slide, in an internet minute, there's almost 500,000 GB of data that is being transferred per minute, which is like humongous. Given the world population today is around 7.3 billion, and assume if everybody is having a mobile phone, that means like 7.3 mobile phones transmitting data every minute. That's almost 1 MB of data that's being transferred from one device. That would contribute to around 700,000 GB of data. So once upon a time we were talking about carrying floppy disk, which was 1.44 MB of data, which was much bigger in size 20 years ago, right? And then came the compact disks, and then came DVDs, which stored a couple of GB of data, and now we have hard disks in the size of terabytes, 1 TB and 2 TB, which is affordable. So the size of the data varies as we evolve in the internet world. Hello, can you guys are you guys okay with my pace? If it's not right, please type on the chat window. Yeah, thanks a lot. So the size of the data has been evolving as the internet has been evolving simultaneously, and we are geared towards a direction of an exponential growth of this information that is pumped up somewhere in the servers in the internet. So this is what happens every minute as we walk, as we talk, as we listen to music from iTunes, as we try to do an Instagram picture, as we try to post a Facebook comment, as we try to tweet about our emotional sentiments. So everybody is contributing to the internet in today's world, and mobile phones and other devices such as tablets have been gearing up this revolution to a vast extent. Now, this is vital for us, that this information is being used as a key to change and to enable decision making as to what we need to do to promote a new product, or to protect an economic scenario, or to understand the social sentiments of a certain country, or even to know the weather changes, or even to order a cab that you wanted to go to a place. So this is what it helps us. Now, this information explosion or the Big Bang theory of internet opens up to vast investments and career opportunities to us. If you could see, as per the Gartner research, around 6 million jobs has been like created globally on the big data industry itself, which is far more than any single industry, even the mainframe industry that was much touted 20 years ago. And today, so the data was a key even in the mainframe times, and data is the key in today's world too. So that's been spearheading the opportunities and investments worldwide, and not just in the US. And every country is poised to build the big data infrastructure to leverage the decisions based on that infrastructure. So this is a typical representation of the investments that's been flowing around in the okay, I see Premanch is saying hello. Seems like he's joined. If there is no question, I move on. Hi Premanch, welcome to the session. So this slide depicts about the investments that's been flowing in the big data industry, and $55 billion is such a huge investment that the projection is looking at. And and this much of an investment opens up to variety of jobs that we would like to. Okay, Elam is saying voice is not audible. Can any of you hear me? Can everybody hear me? So I think Elam needs to adjust his speakerphone probably. Yeah, thanks a lot. So let me get back to my slide back here. So we were talking about the variety of jobs that's been happening in the big data industry due to the huge investment that's flowing around. The first and foremost job that we have is the administrators, as the big data is problem to be solved, and that runs on a cluster of machines. By cluster is a collection of network nodes. So we need people to administer, to manage, to set up, and to deploy such clusters. They are called Hadoop administrators, who are much like Unix administrators, but with proficiency in Hadoop. So, and then comes the second level of the job called the programmers and developers. I think you guys are aware of it, what a programmer and developer would mean. They are the core, hardcore coders who write the Hadoop logic into the Hadoop system. And then we have the future designations that are data and business analysts, who dig in the data that's been collected and stored over a period of time and try to put a meaning to it. You know, this meaning is what very important for companies to make decisions, and that's the core business that's been running around big data. Not to mention these three, the most prominent position is a data scientist. Now, these data scientists are the key people who say the type of the data, who also understand the genuinity of data, who also understand the relevancy of data to any problem domain that's being worked on. And then comes the architects, who are the system designers and specification providers, who will try to define the behavior of a big data system. Now, on the ladder of experience, obviously data scientists and big data architects range much experienced people, and then the mid-level goes to programmers and analysts, and administrators, obviously it's a different level of a job. Now, who are hiring this kind of people? Obviously, almost every Fortune 500 company that we could think of, ranging from Microsoft to Cisco to Yahoo and Amazon. And if you also could observe, these companies are not just software industry-based companies, but they are more into social media and the data-centric based companies too, or sort of a cloud computing companies too. So that's the future that we have been moving around, and many startups other than these companies. Startups B2C and B2C such as Snapdeal, Flipkart, Urban Ladder, and Twitter, you know, they are geared up to hire Hadoop professionals, and Hadoop professionals are being paid enormous amount today, as the resource skills available is very less in the market today. So if you are pursuing a career opportunity in Hadoop, you are you have opened yourself a window towards a greater ocean of opportunities, which with the promising pay packets. An average pay packet of a Hadoop engineer ranges around 105,000 grants, and when compared to the equivalent skill sets that are in demand today. Now, don't you think it's very promising that Hadoop is so exciting and promising for us to think about? But before we get into this, we need to understand what is big data all about, what is the problem of big data, and why Hadoop is required to sort out the big data. Now, to understand big data, we have to start from scratch. We have to understand what data is all about. If I may ask you what data is all about, you might come across to me and tell me it's a piece of information. That's correct. Data is something called a piece of information that is in relevance to a certain context, which will help us to make a decision. For example, if, okay, Premanshu is asking some question. Is that a question?
Yeah, actually, can you tell me the success, what are the vendors of Hadoop actually?
Okay, by vendors, I believe you're asking about the people who distribute Hadoop. So there are many yes. Sorry. Can I go ahead?
Yeah.
Yes. So just like Linux, Hadoop has its own distributions. By distribution, I mean the flavored and customized versions of companies trying to distribute it. Now, Hadoop is originally an open source from Apache. Okay, so this is free of cost to everybody to take it and try it. But the distributions came on top of it, adding customized features and customized ecosystem tools, such as from companies such as Cloudera, which is the most leading supplier of Hadoop today, and then followed by Hortonworks, who is the second leading supplier of Hadoop, and followed by other companies such as Amazon, who's running Amazon, and IBM, and IBM, and even Microsoft running its own Azure platform based on Hadoop. So there are very many versions of distributions that's available, and these are few successful vendors that we have today. And if you want to pursue a distributed version, I would recommend that you go to Cloudera or Hortonworks, as they have the end-to-end system tools set up for you to deliver the software on Hadoop. Is that fine, Premanshu? Hello?
Yeah.
Yeah, thanks a lot. So I was back to the definition of data. Data is a piece of information which will help us to analyze, and make a decision about it. Now, for example, if I may say, in the classroom, I think we have like a couple of participants, and let's say we have Mr. Ashish in this classroom, and Ashish is a name, which is a data. Now, if I may go out to the classroom and call out Mr. Ashish, and obviously he's going to lift his hands up, and then we are identifying who is Mr. Ashish in this classroom. Now, let's assume this classroom is conducted on the same time across India and across the globe. Then we would expect a number of Mr. Ashish to turn up. And if I go and say Mr. Ashish, obviously there's going to be a number of Mr. Ashish to turn up. And for us to identify the right Mr. Ashish, we need some more data. So that's what we mean. We need data to identify the right person here. Now, when such data goes huge in size, we need a way to handle it, right? So that's the size of data is called the volume of data in big data. So as the volume of data increases, we need a way to handle that. Now, statistics indicate the transaction volumes of around 2 million search queries originating in the Google every minute. So you would assume that that's too much of a transaction volume that's happening over the internet. Now, big data is not just volume. If you just say, if you can ask me, okay, if I have like 500,000 GB of data, can I say it's a big data? Yes, you can say it's a big data. But even if you have like 500 GB of data, but you think that it's going to be in a variety of formats, such as images, pictures, video, and MIME contents, it could be anything, a different sort of formats, then you would obviously try to treat it as a big data, because you need a way to make them store it in unstructured format, and you need a way to retrieve them as an unstructured format or a structured format to process the, the analytics that you would like to process. So big data revolves around these three V's called volume and variety, and the third V stands for the velocity, which is obviously in the plain physics, it's speed by time. So number of transactions happens per second or per minute, and obviously the big data infrastructure needs to handle such humongous amount of volume in its own space. In the times of Hajj, right? I mean, a lot of people go to Mecca and Medina, and during the time of Mecca and Medina, everybody prays to God, and then suddenly they start to make a call, and you would suddenly face a phenomenon that the whole network tower goes off. That's because of the millions and millions of transactions happening in a certain second that the networks cannot handle it. So this is the problem that exists with big data. What happens when millions and zillions of information is flowing across the internet and the infrastructure is not able to handle it? So big data's challenge is that it has to handle it. So that's what the third B stands for. It's the velocity that it has to support. Now, given these three V's, that big data has a big challenge, and it has to ensure these three V's are satisfied in the right manner. We are going to talk about the fourth V that remains as a perennial challenge for big data. Now, there is this joke actually. There's this Flipkart customer care center, right? I mean, you guys know about Flipkart, and there is this customer care center. And why do you use a customer care center for? You just have your problems of your product that you purchased or the service you had. So you call up a customer care center, and then you tell them, okay, I have this problem about this product that I purchased from Flipkart. Can you please help me? Now, there is this guy who calls up Flipkart, and then the customer care center guy answers him, yes sir, this is Flipkart, what may I do for you? And he says, okay, I have a big problem, I have a question to ask you, it's bothering me a lot. Then the customer care guy thinks that it's a problem with the product, and he says, yes sure, obviously we are there to help you. Then this guy comes and asks, okay, who killed, why did Katappa kill Bahubali? Now there's a big joke that's been floating around the internet world, but what is the relevance of this joke into this context of the session is that in a Flipkart customer care, do you guys think that this question is relevant to a customer care person? Anybody? Do you think this is relevant? This is an irrelevant question to a customer care guy, right? Talking about something else when it is not related to the product or the service that Flipkart was selling. Now, this is the key challenge in the big data world, because big data, the information of big data comes from the people. You and me pump the data into the internet, and if you and me do not pump the right data, then the decisions that we are going to make from the data is totally going to be wrong. So the challenge in the big data is to identify the right data and its relevancy to the problem domain that we are trying to solve. Now, that's the fourth V, and it's called veracity, V-E-R-A-C-I-T-Y, which stands for truth. Nevertheless, big data also has its other challenges because it's a networked infrastructure. Any challenge connected to the network in terms of data access and connectivity, and in terms of security on the network, because it's prone to hacking, and in terms of integrity of the data, these do exist in the big data world, and they need to be addressed simultaneously. And as big data is an evolving technology, things keep changing very, very fast, and it makes us to adapt. It wants us to adapt faster too. I mean, that's another challenge that we face in. Now, in order to address these challenges, that's where we have a solution, so-called Hadoop. Now, we are going to see what's Hadoop's role in addressing these big data challenges. Hadoop is generally, in plain terms, Hadoop is a software platform, right? It's written in Java code, and it's trying to address some problem that we talked about, all the problems of big data. What are the problems of big data? Volume, right? It needs to satisfy huge amount of data. It needs to store them somewhere in an efficient way and in a cost-effective way. Then the second thing was Yeah, I think Mr. Premanch is again asking me a question. The question is, can you please tell me the difference between Hadoop and big data? Okay, big data is a problem domain. Okay, Hadoop is an answer to the problem domain. Hadoop is a software implementation of a platform which is trying to address the problems that the big data raises. If you may call, does this answer or does this answer, Mr. Premachu? Hello?
Yeah, actually, can you means bit clear means are you telling that Hadoop is a framework or something like that or what?
Yes, Hadoop is sort of an architectural framework which tries to address the problems of big data, and the problems of big data are the four V's: the velocity, volume, variety, and the veracity. So Hadoop is trying to address the three V's at first.
Yeah.
Okay, so now we're going to take about the how does it address the volume. The volume, as we talk about, volume is all about size, and we need a way to store this huge amount of data in a manner which is easily accessible, which is redundant, and which is cost effective. Now, second thing comes the variety. We need a storage which would store, or we need a way mechanism to store whichever way you want to store. For example, in this classroom, let's say we take like three participants. Okay, everybody feels, all the three feels happy. Now, now the first participant is trying to write in his Facebook as happy, I am happy, on a plain English, okay? And the second participant puts this as a smiley. And the third participant tries to upload a video of him dancing to show that he's happy. Now, if you see the meaning or the context here is happy, but the variety of expressions of happiness is different. In the first case, it was a text. In the second case, it was a smiley, which could be an image. In the third case, it could be a video. Now, we need a platform to store a certain context in very many formats. That's what Hadoop is all about. Okay, Hadoop tries to ensure the data is stored without manipulating, without processing, and when it is stored. And the third V is the velocity. Because of Hadoop's computing framework, it can handle a huge amount of transactions of volume. So Hadoop is a simpler architecture, and I think, yeah, origin of Hadoop. Yeah, up until any questions on how Hadoop solves this problem of big data. Yeah, YRD. I don't know what is YRD means. Mr. Elam is asking YRD. Can Okay, I think I'm continuing with the velocity and volume. Yes, it's like this. You have your mobile phone, correct? Let's take a simple example. You have your mobile phone, and it has a certain capacity. For example, you go and buy an iPhone, you buy a 16 GB or 32 GB, right? Now that's the size, that's a memory size. You know, in big data, the size relates to volume. Now, in your mobile phone, you make calls and you make charts. You can do more than one thing at a time, correct? And in a certain given minute, you can browse. You can browse on a browser. You can do an app store, and you can try to do a WhatsApp chat. You can have a voice call. Yes, let me finish the velocity and volume, and then I address it. You can have a voice call. So in a certain given time, you're doing too many things, right? Too much of transactions that are happening. That's velocity. Velocity is all about doing too many transactions in a certain given time, and volume is all about the size of the transactions, right? Does it address you, Mr. Elam? Yeah, and yeah, and the difference between big data and Hadoop is this. Okay, yeah. So big data is something like a ocean of water. Okay, it's like an ocean. Okay, which is just filled with water. And Hadoop is something like a boat where you want to use it to cross the ocean. So how do you put it in the technical terms? Is that big data is a domain. Okay, big data is a domain which has its own challenges. For example, every domain like mainframe has its own challenges, and telecommunication has its own challenges, and databases. What databases has its own challenges, right? And the implementation of a solution for the challenge is the platform that we call as Hadoop. Okay, there is okay, so that's the thing. So uh, the problem of the data that we face in today's world on the internet is the big data, and the solution, one of the solution to address the problem is the Hadoop, and the solution is a software solution, also combined with the hardware in terms of clusters. So now going back to Hadoop's history, Hadoop started way beyond in the year 2000, when slowly coming up into something called as a most popular search. Google came up, the pop, I think they just exist as domain providers, but they don't exist as search engines. Google has transformed themselves wide enough. Now, at that point in time, the person called Doug Cutting, there's a person called Doug Cutting. He was the Internet Archive Search Director, and he was assigned the task to find a better way of indexing the web pages. Okay, so what he would compute, and he had some amount of web pages, and he was assigning each and every computer this bundle of web pages to index. Now, at that point in time, his colleague, Mike Caravella, who was a Stanford University graduate, or maybe I think a Harvard University graduate, I'm not sure which university it is, but yeah, he was a university graduate at that point in time working with Doug, and he bounced upon this Google's papers called MapReduce papers, published in the next year. Now, he figured out Google was doing much similar to what they are doing, but Google has a cluster computing framework. So he went with a paper to Ms. Doc Cutting and then told, listen, Doc, these guys have been doing the same that we are doing, but it's just that they have a software implementation of it. So why are we trying to manually allocate the jobs to each and every computer of which? That's when Doug and Mike started writing the code to do this automatically based on the MapReduce algorithm that Google's paper was talking about. Okay, that was written in Java, whereas Google's MapReduce was written in C++. So Doug Cutting wrote this thing in Java and named his whole project as Nudge project. Now, after a few years, this project was adopted by Yahoo because they hired Doug Cutting, and later on, Yahoo tried to cut off the core components, which is the MapReduce and the distributed file system, and spin it off to the open source world called Hadoop. Now, the Hadoop name of the Hadoop came because Doug was asked to name it, and he doesn't have a name at all. When he bounced on his little boy, or his own kid, who was playing with the elephant toy. The elephant toy is a stuffed toy, and its name was Hadoop. Now, Doug gave this name because he thought Hadoop should be something like easy to play with for everybody, but it should be still as big as an elephant that it can handle humongous volume of data and things like that. And that's the reason Hadoop is formed. And then Apache open source Hadoop was actually spinned off. And since then, there is no looking back for Hadoop. There's been companies adopting Hadoop. Primarily, Yahoo was the first thing to adopt in a full-scale version of deployment, and then comes Facebook, and then Doug leaves Yahoo to form his company called Cloudera. And meanwhile, his own colleagues leave the company and then form another competing company called Hortonworks. That's why in today's world, two companies remain as a major vendors of Hadoop, Cloudera and Hortonworks. This is how Hadoop has transformed itself over the decade into a metamorphic solution to address a big data problem. And the architecture of Hadoop is very, very simple. It needs to have a storage component to store the volume, to store the variety, and it needs to have a MapReduce component to handle the variety and to handle the third one, the velocity of transaction, correct? This all Hadoop is all about. So Hadoop has two components. One is called the HDFS, stands for the distributed file system. One is called the MapReduce. Since then, there are many other supplementary projects that started all around Hadoop, and they all form as an ecosystem to enable Hadoop as the strongest big data solution and some of the ecosystem are tools are Pig, Hive, HBase, Flume. Everything is used for a certain purpose. Now, Hadoop runs on a cluster of machines. It doesn't run on one single machine like we had. So Hadoop runs on a cluster of machines, right? Can you store 1 GB of data in a laptop? The answer is yes. Can you store 100 GB of data in your laptop? The answer is yes. Can you store 1 TB of data in your laptop? The answer is maybe. Can you store 100 TB of data in your laptop? The answer is most probably no. What do you do with it? You simply store the same data, 100 TB of data, split it, store it across 2 or 3 laptops. That's what Hadoop is all about. Hadoop stores this volume of data that's coming from the big data world into a cluster of machines, which are cheap machines like a laptop or a desktop or even some sort of servers that would store the data server that would store this data. So these cluster missions are called the nodes, and the nodes form the primary component of yeah, Mr. Rajiv is asking some question. Big data is a problem, then how would you handle the huge data? Can you handle that with Hadoop? Yes, that's what exactly we're talking about. Hadoop is a solution to handle the huge data, and how Hadoop handles is by having a cluster of missions, cheaper missions, right? See, the data existed even in the olden era. In the mainframe world, similar amount of data existed, but then we had a big mainframe storing the data. In today's world, we don't have big mainframes. Mainframes are actually obsolete now. We have this cluster of machines that will store the data. That's what Hadoop is all about. Is it fine? Does it answer, Mr. Rajan? Okay, thanks. Thanks. Now, Hadoop's principle is very, very simple. Because you can store the data into more than one machine, you can keep on adding the machine as much as the data grows. So it's a scalable architecture. And even when one laptop goes down, the data stored in the laptop is going down. Hadoop is very, very reliable because the data is somewhere redundant in some other laptop. And how it retrieves is the architectural thing, which we can see later. But that's why Hadoop is a very scalable and a reliable architecture. And because yes, we have a Q. Yeah. So, and because we have this storage that's been done on cheap computers, it's because of the cluster architecture. Hadoop is very yes. Mr. Elam, yes, you have a doubt. What's the doubt? Yeah, go ahead. Okay, he's not raising his doubt, so I will reserve it to the Q&A session. Okay, there's a doubt coming in here. We suppose if you want to analyze some 10 GB of data, extract write information from 10 GB, do we need some spread across 10 GB across? Yes, the answer in a nutshell is yes. We need to spread the data in all the missions if the capacity is limited. But I think we can I can explain it to you at the end of the session how we can do that. Right? So going back to the Hadoop characteristics and principles, since the cluster architecture is very, very scalable and cost-effective and reliable, Hadoop is most widely used as a solution for the big data, and Hadoop does not verify the data when it is stored. For example, in the RDBMS world, when you wanted to store a data, it is always validated against a schema. In Hadoop, it's not like that. It just stores the data as and when it comes, and as and how it comes. So if you're going to put a picture into it, it just stores a picture. If you're going to put a video into it, it just stores the video into the hard disk. And then if you put a text, it just stores the text into it. So it does not differentiate. Only text needs to be stored or only video needs to be stored. It just stores everything. You can think of it as like a big trash can where everything is trashed into it, and then the meaning of the thing is done only when it is fetched back from the trash can. So, which is why Hadoop has to work on very, very large data sets because of the multiple access to the data. It's very costly if you keep on reading the data each and every time. So you need to have like large data sets for it.
So Ramesh, sorry to interrupt. Hello, Ramesh.
Yeah, hi, who is this?
Am I audible? This is Primanshu. Sorry to interrupt actually. So as you told that it's a kind of place where all the data is getting stored, where there's no data type declared for it. So suppose when the person used to fetch the data, so how is fetching the data at a very minimum time actually? Means how it's sorting the data and how
In
it's
order to in Hadoop, in order to fetch the data, that's when the definition of the data needs to be made. Okay, so you need to know what kind of a data that you're going to fetch. I mean, that's where the ecosystem comes in place. If you use a map reduce program, or if you use a pick tool, that's when, or if you use Hive, that's when you define a schema that you would like to process an image, and then you go and fetch the images.
Mhm.
Okay, so while storing, there is no schema being written, but while retrieving back, there is a schema that will be written. So that's where the
So
logic, that's where the difference comes.
So tell me one thing. So suppose if a person that is okay, that means the data what is getting stored is in the format of no data type. Okay, but when getting fetched by the person is getting for as per the data type. Correct. So
Correct.
suppose a person come back. Okay, boss, he want to search something related to some key type or some keyword like nature. So how is fetching data? Because when we give the word nature, it could be image, it could be any kind of type of things which is going to be fetched. So how is going to be in that case? How is going to retrieve the data and how is going to present the data and how is
Yeah.
going to
In
take it
in
out faster?
typically in typically if search engines used to work with something called an indexing, right? You know,
Yeah.
for every keyword there is some sort of an index generated with respect to a hash key or something like that. So when the same keyword is called off, the hash key retrieves the same location. That's how indexing used to work. That's how search engines searches used to work. But Hadoop search query is in turn different. That's what we call it as map reduce here. Now the map reduce takes the key and runs across all the data sets of the cluster that's being managed, okay, looking for a plain one-to-one comparison as per the logic that the map reduce program is written. For example, if you have stored the data of nature, let's say you might have assigned a tag or a keyword, or you may not have assigned it, you know, and this data is stored like across 3 missions, and Hadoop, when you fetch it, Hadoop will run the query and across the 3 missions and fetch whatever returns that thing, and then it's up to the MapReduce program logic to even filter it furthermore. So there is a series of MapReduce programs that the user will be that the programmer will be writing to fetch the right set of data for the query that's being given. Okay, so it's not the traditional way of indexing here, but it is something called a map reduce. That's a map reduce is a key algorithm that does this job. Now, now in the olden era, we used to pass. Hello, can somebody mute it, please? It's yeah. Hello. So in the olden days, we used to move the data across the processors so that we can compute it, right? Now moving the data is costlier because you need memory. Number two, it takes a lot of time because you need to do a lot of I/O operations or DMA transfers. Now in Hadoop, it's the other way around. Everything is the other way around. We move the processing close to the data, which means the MapReduce program task will run on the node that has stored the data, or will run on the nodes that have stored all the data, rather than data is being fetched and put into a computer that is doing the computing. Now that's a key principle of design that Hadoop works on, which is why MapReduce is very, very powerful in running this job, and this is where it is faster than a traditional way of indexing and retrieving the things. Another thing is Hadoop is by default fault-tolerant architecture, which means if one node goes down, it needs to still work in the same manner as it was working before. And the data that is stored in the Hadoop system is a file system model, which means it's very easy for a programmer to 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 visualize the data that is being stored as files, and then read the files and write it into the files as per he wishes. So these are simple key principle designs that Hadoop has made it more prevalent and answer the solution to the big data. Hadoop comes in two versions in today's world. One is 1.0 and next is 2.0. Um, 1.0 is the most prevalent architecture and most deployed architecture in today by many companies, and 2.0 is trying to replace them. The major difference is in the way it is being scheduled. In Hadoop 1.0, it's a master-slave architecture where there is a master trying to schedule the MapReduce jobs on all the slaves. In the Hadoop 2.0, it's a yarn architecture. Yarn stands for yet another resource negotiator, and it tries to negotiate before scheduling any job with the cluster nodes. So it's not a master slave, it's sort of a peer-to-peer, it's sort of a resource negotiating architecture. And that's where Hadoop 2.0 scores more over optimized resource usage in a cluster. Hadoop 1.x was primarily a MapReduce job, which supported Hive and Pig and other ecosystem tools. In Hadoop 2.0, MapReduce runs as a separate ecosystem job on top of the yarn, and also with the support to run many native applications such as MPI. You guys know what MPI is? I mean, MPI is a multi-programming interface thing, which stands for in a mainframe world, people used to write mainframe computers to compute on the data sets that's stored in the mainframe cluster, mainframe servers, right? So in order to ensure the similar mainframe structures are used in the current Hadoop data storage, because there's a story that's different, we use the MPI interface to do that. And we have Spark. Spark is something like an in-memory processing platform, which is very, very powerful to do the online transaction, online and real-time processing of the data that comes in, right? Hadoop does not do real-time data processing. Hadoop wants the data to be stored and then fetched and then processed. But what if you do not want to store the data and then process it? What if you want to process the data as and when it comes? That's when you go for Spark. And then there are applications such as graph tools, which are required for visualization and plotting of metrics for analytics. So Hadoop 2.x is much versatile in supporting all these applications with a better resource negotiation architecture. But the underlying storage is still HDFS, which is the Hadoop distributed file system, which tries to split the files and stores across all the nodes. Yeah, with this we almost try to come to the end of this introductory session, and the detailed sessions contents are here, which talks about details of the HDFS architecture, yarn architecture, and some of the ecosystem tools such as Hive, Scoop, Flume, HBase, which is a database on top of Hadoop to define schema and then to retrieve the information, and Uzi in Spark. Spark is the in-memory computing that we see, and also talks about commercial distributions of Hadoop. Who are the major vendors and what are the licensing schemes that they got, everything. So yes, now we can move to the Q&A session. I think the question that was followed up was Mr. What was that? How the 10 GB data is stored. Somebody was asked this question. Mr. Elam was asked this question. Now it's like this, right? If I have 1 GB machine, let's say I have 1 GB cluster machine of help. Yeah. Let's say we have 1 GB cluster and we have like 10 nodes, which means every laptop I have is a cluster and every laptop size is just 1 GB, and the data I want to store is 10 GB. Obviously, I cannot store 10 GB in one laptop. I need to spread these things on all these nodes so that it is equally split as 1 GB and stored across. That's how it is being stored. And another thing is, Hadoop does not store file as a file. It stores something called a data block. So even a file is split as a data block, and then they are split and then they are stored into the Hadoop file system. Is that fine, Mr. Elam? Does that answer your question? Yes. And the second question comes from Mr. Rajesh. As there are several tools under Hadoop, which tool? Yeah, that's a good question that you've been asking. The most tools that are used under Hadoop are Hive and HBase. It depends on what eventually you want to do. If you want to retrieve the data in a SQL format, or you have SQL queries already, but you are using a data storage as Hadoop storage, then Hive is a tool that you have to use. If you want to do more of a real-time processing, let's say you have a B2C website, and you want to handle the transaction volumes under the card, that comes from the consumers. So it's a real-time processing that you need to do. Then you will go ahead and use a Spark programming interface. And in such cases, if you want to already model a data set based on Hadoop, then you will use HBase. But the most prevalent tools are these three: Hive, Pig, and HBase. With respect to tools, with respect to the programming paradigm, you have to learn Spark. So these are the four essentials for any Hadoop pursuer wants to get into the Hadoop industry, needs to follow this up. That is fine, Mr. Rajesh? Okay, one by one, please. One by one, please. Mr. Lakshmi Narayan says, I'm from mainframe background. I should be knowing Java. That's not required. That's a misconception that everybody has. Java is required to learn big data and Hadoop. Java is preferred, not mandatory. To speak the truth, if you know Perl or Python, you can still use Hadoop with the streaming APIs. If you know mainframe, the best thing for you is to learn the MPI interface where you can still write your mainframe code and still run on Hadoop. Is that fine, Mr. Lakshmi Narayan? And I'm going to Mr. Rajesh query. Do we need to know programming language? Can we use only SQL query? You can use only SQL query, but then you will have to rely on one of the ecosystem tools such as HBase or Hive. So it's not must to know a programming language, but it is preferred to know a programming language because the core logic is a map-reduce logic, which is written in a programming language. And Mr. Ashish, I think the answer, it's already answered, Mr. Ashish, or is there something else pending? Yeah. Any other questions? Yeah, Mr. Premanshu is saying hello. Hi, hello, Premanshu. Any questions?
Very first thing is that what is the major scope of a Hadoop administrator and major Hadoop administrator profile work here in this domain? Is only to set up a cluster or to maintain it, or what other than those things are there?
Yeah, Hadoop administrator jobs are this. He first needs to set up a cluster, which is a major job that he has got because there are a lot of configuration files that he needs to set up. So number one is this. Hadoop administrator tries to understand how the cluster architecture is, whether it's 1.x or 2.x, and sets up the cluster accordingly. Number two is that he tries to set up all the ecosystem tools, including Zookeeper and things like that, so that every other ecosystem tool learns about the Hadoop components. Number three is, yes, periodically managing and maintaining it, the Hadoop cluster. These are the biggest jobs for a Hadoop administrator.
So in case of maintaining the Hadoop cluster, what is the job exactly? Means like what? Like in case of DBA, we have to, mostly the DBA jobs are mostly now is managing and maintaining the database. So it's all about like taking the backup, restore, recovery, cloning the database, and multiple jobs are there. So in same way, what is the managing scope of Hadoop administrator?
He needs to ensure that the daemon process are running properly, and he needs to ensure that the cluster, if the node goes down, and then the data blocks architecture are set up properly. So there is a periodic check that he needs to perform, so that the Zookeeper is configured according to the right configuration. So every other components of Hadoop can work with it. So it's a periodic job that he has got. His major job is in the deploying part. So right now, Hadoop data is not really backed up, but I think, yes, companies are talking about backing up Hadoop clusters. So that's also one part of the job that Hadoop administrators have.
Okay.
Okay, profile of a data scientist. I think we talked about the veracity of information. That's the key job of a data scientist. Can somebody mute the speaker, please? It's too noisy. Yeah, thanks a lot. So we were talking about the genuineness and relevancy of information, right, Mr. Rajesh? I mean, we talked about this Flipkart joke of Bahubali coming in, right? It's a data scientist that defines whether the data is relevant to the problem or not. And if it is relevant to the problem, what kind of data that it would be. He needs to identify the data type. He needs to define the data type, and he needs to understand its genuinity, its truth. This is why data scientist job is very key job, because if he identifies it wrongly, then 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 the decisions based on that is totally wrong. The analytics are totally wrong. So that's a more prominent job in the Hadoop hierarchy. What are the basic technology which we should know to start on Hadoop? Do I know DB language? SQL is preferred, and usage of Linux is preferred, but 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 these are the user level, like how you use your Windows computer. You need to know how to use a Linux machine. That's it. And yes, SQL is preferred, but these are preferred. What is core important is to understand the Hadoop's architecture and how the MapReduce works to really push yourself into Hadoop. Is the skill relevant to project managers? Indeed, yes, because project managers going to run Hadoop projects needs to know how the Hadoop cluster is all about, and so that he ensures that the infrastructure setup is done. He ensures that the ecosystem tools are done. For example, if you want to do a job, let's say that you have stored some data and you want to fetch the employee database. Let's say all your employees who has joined on a certain date and things like that, right? So it's you need to decide which tool to use correctly. That's the job of a project manager. You can use many tools, as Hadoop ecosystem is like vast. There is Hive, there is Pig, and things like that. It's a job of a project manager to ensure what ecosystem tool needs to be used on that, and how that ecosystem tool will help you address the problem for the Hadoop project. So yes, it is relevant to a project manager. Any other questions? Mr. Elam is asking, I am an Oracle Apps DBA. Can you please tell me whether to become Hadoop admin? Do I need any programming language, developing any? You are a database administrator, right? If you want to be admin part, how easy to? Well, the DB administration is totally different than Hadoop administration, because DB administration works on a database concept. Hadoop administration works on a file system and a cluster concept. So I think if you want to pursue the administrator line, you need to understand the Hadoop's architecture and its core configuration principles. Once you know this thing, it's very easy, because the challenge is in the deployment part. Programming would be tough for you, because you need to learn some amount of programming skills, if you know SQL, then it's very easy to get into programming skills. So it's what you want to do eventually. If you know SQL, I think programming is well and good. If you do not know SQL, then yes, Hadoop administration is well and good. Is it fine? Any other sessions? Any other questions? Okay, thanks a lot, guys. Which tool is from IBM for big data? IBM has something called Big Insights distribution. I think people who want to pursue IBM thing, they have to buy the distribution called Big Insights, and that's what is big data platform is all about from IBM. Yes? Any questions? Can we wrap up? Okay, I think we are done for the day, and thanks a lot for participating in this session. Okay, there's one more question coming up. I'm a .NET developer and automate the IT process. Okay, Mr. Raju. Well, you are from Microsoft world, and Hadoop also has a distribution coming up on the Windows system, and by automation I mean you're in a scripting world. So if you know scripting language, you have to adapt yourself to learn something like a scripting tool like Pig to adapt to Hadoop world.
Okay, I'll better speak here. So I just wanted to check how Hadoop can help me to improve or add some values in my job function.
I have no idea what your job function is.
Okay, as I said, I'm a .NET developer, and which requires a lot of business logics, and I need to communicate with different databases. So we often find that database creates a lot of problem when there is a huge data, right? And pulling the data in a smarter way from the database and showing it on the UI is quite challenging sometimes. So is there something Hadoop can add some values there?
Actually, I think the key difference is Hadoop does not work on a database. Hadoop works on a data storage, right? And the data storage is typically a file system on a cluster. So the key important that you need to do is you need to move your data storage from databases to Hadoop storage. If you do that, yes, then you can use one of our Hadoop platforms tools to pull the data and to do the analytics, and that's what companies are trying to move on to migrate from a traditional way of database way of working or a ETL working to the big data and Hadoop way of working. So the key importance here is you need to move your data storage right from database, or up until now if you've stored in a databases, then you need to start putting them into a Hadoop cluster and then start retrieving the data from a Hadoop cluster or from both using tools such as Scoop and things like that.
Okay, so that will be
Yeah,
faster, right?
that is faster. Yes, that is faster and that is cost effective. I think the companies are moving towards Hadoop because it's faster, it's very cost effective, because it's very difficult to afford huge computers and data storage servers and maintain the real estate and logistics and things like that. So it's easy if they get into a cluster-based architecture. That's why companies are primarily investing in Hadoop clusters a lot.
Okay, sounds good. Yeah.
Yep. Any other questions, please? Okay, guys, I think we are done for the day.